thought I'd do just one extra example with this completing the square process because it is important that we do know the steps involved here. All right, so you're faced with a quadratic equation. Again, we know it's quadratic because of x squared. You might want to check to see if you have a linear term because the square root property is pretty fast. Unfortunately, that 20x kind of does not allow us to use the square root property. So if you're not planning on trying to factor this, and don't get your hopes up, many of these do not factor. So let's just go with completing the square, show that process one more time here. Okay, step one of the process, remember, is to, I said isolate the constant. So right now the constant is on the right side. That's where it needs to be, but it's being joined by this 20x, so I'm going to subtract 20x from both sides. So 2x squared minus 20x equals negative 32. That would be my first step. Get the constant isolated, preferably on the right side. Okay, step two. Do not forget this step. A lot of people skip this step and go right to step three. Step three doesn't work if this is anything but a 1. So it needs to be a positive 1, meaning I have to divide by that quadratic coefficient of 2. That means every single thing in this equation gets divided by 2. So 2x squared divided by 2. Negative 20 divided by 2, and negative 32 divided by 2. All right. So x squared minus 10x equals negative 16. Step 3. Step 3, I kind of consider it like my scrap work step. I'm trying to figure out the number I need to add to x squared minus 10x to get a perfect square trinomial. Well, the trick is we're taking 1/2 and multiplying it to our linear coefficient, which is now negative 10. So 1/2 times negative 10 is negative 5. And don't forget, we have to square that result. We get a 25. We'll put that in a box, because if I add that to x squared minus 10x, I get a perfect square trinomial. I am completing the square. I'm making it a perfect square trinomial. So step 3 is kind of like I said, it's just scrap work. So I'll put that in a box, but now I know I need to add 25 to the left side. And step 4 says I got to add it to both sides to keep the equation balanced. So in step 4, we're going to rewrite this as x squared minus 10x plus that 25. And I like to keep it in a box just to show what happened from step 2 to step 4. So negative 16 plus also that 25. So you can see that 25 being added to both sides of the equation. All right, but the left side, that's a perfect square trinomial, and I can prove it to you. That's x times x. That's 5 times 5. If you take one of each, multiply them together, you get a 5x, multiply that by 2, you get your middle term. So since it's a perfect square trinomial, guaranteed it will be if we follow these steps. Step 4, you will have a perfect square trinomial. We're going to factor it as a single binomial squared. So step 5, we factor x squared minus 10x plus 25 as what it is, a perfect square trinomial. So x and a 5, the middle sign will be minus, so x minus 5, quantity squared, equals, well, negative 16 plus 25 puts us at something. We got 9? I believe so. Oh, this one came out nice. So x minus 5 quantity squared equals 9. And step 6, we're going to square root both sides of this equation. So x minus 5, I'm sorry, we're using the square root property. We are square rooting both sides. So you have a number squared equals 9. So that number, x minus 5, has to equal plus or minus the square root of 9. Now, in this case, this came out really nice because the square root of 9 is just going to be 3, or I should say plus or minus 3. Then we add 5 to both sides. We want to know what x is. Now, unlike the last problem where these were not like terms, one was a square root, the other was not, these are not square roots. You can add and subtract 3 to another, rational number like 5. So what we have to do is say x is equal to 5 plus or minus 3, but I would hope you would never leave that as your answer. You'd never say your answer is 5 plus or minus 3 when you can actually add and subtract those. So we're talking about 5 plus 3, or you're talking about 5 minus 3, which means x could be 8 or x could be 2. Those are my solutions. So 5 plus 3 is 8, 5 minus 3 is 2. So 8 and 2 should be the solutions to this quadratic equation, solving using completing the square. Now, looking at my answer, since there's no square roots involved, this could have been solved by factoring. And it would have been faster, true enough. But, if you're not wanting to factor, or, the problem just doesn't factor, completing the square is not going to ever fail you. It will always work. It will always give you the solution to your quadratic equation. Even the times when you could have taken an easier method, it still works across the board, which is what's nice about that. Okay, so what I want to do is just try a messy one. Just to show you that it doesn't always come out super pretty, but we can still solve it using completing the square. So I guess at the very least I can save some of these steps. All right, so let's try something like about 5x squared. Oops, better put it up here. Say we were asked to solve 5x squared plus 15x minus, what sounds good, about 35. Now, I have no idea if this actually solves nicely by factoring, and I don't care. I'm going to use completing the square to solve this. Okay, well, step one, first of all, we're going to add 35 to both sides. So isolate that constant. So 5x squared plus 15x equals 35. Step two, very important, I have to divide everything in this equation by 5. Now, I made sure that they were all divisible by 5, but, this is going to be messy enough as is, but it could get even messier than what we're about ready to see. But dividing everything by 5, I get x squared plus 3x equals 7. Now, in step 3, the idea is we're going to complete the square. Now, this one's not so obvious. Follow the steps. That's 1/2 multiplied to my linear term of 3, which is 3 halves. The temptation is to want to call that 1.5. Don't do that. Keep it as a fraction. Right? And then take that fraction to the second power. How do you square a fraction? You square the numerator and the denominator. So 3 squared is 9. 2 squared is 4. Right? So we can put a box around that. 9/4. You're now going to add 9/4 to both the left side and the right side here. So x squared plus 3x plus, as weird as it looks, 9/4 equals 7, also plus 9/4. Okay, now, I can show you that this is, in fact, a perfect square trinomial. Nothing like we've ever factored before, because we generally don't factor with fractions. But that number needed to be 9/4 in order for this to work. So this is a perfect square. It's x times x. 9/4 is actually, in theory, a perfect square. It's 3 halves times 3 halves. If you multiply one of each together, you get 3 halves x multiplied by 2. 3 halves x multiplied by 2. The 2's cancel. That gives you 3x. That is definitely a perfect square trinomial. So it still works. So when we go to step 5, that gives us a pretty strong clue of what we're going to need. Well, obviously an x and a 3 halves. And in this case, we're going to need a plus. So x plus 3 halves quantity squared equals, and not to be outdone, we have to add 7 and 9/4 together. Well, the short way is to call this a mixed number. That's a very bad form, 7 and 9/4. But then you can turn this into an improper. You remember how? 7 times 4 is 28. Add 9. So 28 plus 9 is 37 over 4. Otherwise, you got to get common denominators. I guess it's not that bad. This would be, what, 28 over 4, 28 plus 9, 37/4. Any way you slice Okay, step 6, use the square root property. If x plus 3 halves squared equals 37 fourths, then x plus 3 halves equals plus or minus the square root of 37 fourths. We'll clean this up for sure. That's x plus 3 halves equals plus or minus, split it up top and bottom. Square root of 37 does not simplify. Square root of 4 does. It's 2. So x plus 3 halves equals plus or minus square root 37 over 2. And then subtract 3 halves from both sides. And again, these will not combine. They're not like terms, like radical expressions. So x is equal to, we'll write the negative 3 halves first, then put the plus or minus square root 37 over 2. And we can leave that as our final answer. So the solutions, they're not pretty. I wasn't expecting them to be. You got to understand, this will solve any quadratic equation, even if the solutions are imaginary, which is kind of nice.